So in this section, we are going to look at radical expressions and combining that with some of our power rules that we looked at in the last section. So first things first, make sure that you know the index right here is the power on the outside. The thing that goes under the root right here is called the radicand. And then we have the radical symbol, the little root thing that we draw. So the first rule is something that I talked about in the last section, that I can write a power, or a fractional power even, as a radical or as an exponent. So for example, let's say I had x to the 2/3 power. This is the power over the root. So I can write that as x to the second power with the third root, which is the exact same thing as saying the third root of x and then squaring it. Either one. These two are equivalent. One thing to note is what's listed right here is that the nth root of a is called the principal root, or the positive one, whereas the negative nth root of a is called the negative root. So we're going to rewrite or write what we are given with exponents instead of roots, and we are going to evaluate. So if I do letter A, I can write that as 16. It has the first power, and it's the fourth root. 16 is 2 times 2 times 2 times 2. So when I take the fourth root of this, I need to make one group of 4. What I remember is that the number on the outside is the rule, or the size of the group. I must make a group of 4 to have anything come out. So I made one group of 4, so 1, 2 gets to come out, which means that the fourth root of 16, or 16 to the 1/4 power, is 2. Letter B is very similar, except I have a negative out front. So I have negative, and then I'm going to put some parentheses around it, fourth root of 16. So I can write that also as negative 16 to the 1/4 power, which is a negative 2. Because this piece right here, we proved over here, is equal to 2, and then I just took the negative that was in the front and put it down here in the front. So here's my answer. Letter C is a little bit trickier. So what letter C is, it says negative 32 in parentheses. The negative is under the root, and then it's raised to the 1/5 power. So if I'm going to do this, I need something 5 times that makes 32. Well, 2 times 2 times 2 times 2 times 2 is 32, because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. But because it's a negative underneath, I have to make them all a negative. Because a negative times a negative makes a positive 4, times this negative 2 makes it a negative 8, times this negative 2 makes it become a positive 16, times the last negative 2 makes it become a negative 32. So the fifth root of negative 32 is negative 2. Letter D says, what's the third root of 1,000? Well, 1,000 is 10 times 10 to make 100, times 10 more. Again, this is the size of the group. So I make a group of 3 things, all the same things, because I made one group, 1 10 gets to come out. So my answer is 10. And I can rewrite this as 1,000. It has the first power on it, and I'm taking the third root. For letter E, we're going to rewrite this and put the root on top. So I'm going to take the 6th root of 64 on top over the 6th root of 729 on bottom. The 6th root of 64 is the same thing as saying 64 to the 1/6 over 729 to the 1/6. The sixth root of 64 is 2. And the sixth root of 729 is 3. Letter F that's a tricky problem. The answer to this problem is not possible. And the logic behind that is the following. This says the fourth root. So I need something 4 times. So 1, 2, 3, 4. Well, if these 4 things, they either have to all be positive or all be negative. They can't change. They have to be exactly the same. So if I do positive, 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 a positive times a positive is positive. A positive times another positive is still a positive. Times another positive is a positive. Well, I don't want a positive. I need a negative. So let's try one more time. Let's try with negatives. So if I do a negative times a negative, these two make a positive. Times another negative makes this become a negative. Times another negative makes this become a positive. Well, both ways I have a positive, so there's nothing that I can take times itself 4 times to make a negative number. So we're going to keep using this rule, and we're going to just rewrite this stuff in the next example. So I'm going to rewrite this in radical form. So this is 8 squared. I'm going to take the third root of that. I guess I really don't need those parentheses. Okay, well, I also can write that as the cubed root of 8 and then squared. The cubed root of 8 is 2, because 8 is 2 times 2 times 2. So this part right here results in an answer of 2, but then I still have this square on the outside. So 2 squared is 4. My final answer is 4. The next one is negative 32, and this is just my preference. I like making things smaller before I make things bigger. So I'm going to rewrite things like this instead of this. That's just my personal preference. I like it to make things smaller before I make them bigger. So the fifth root of negative 32, and then I'm going to raise that to 4th power. On the previous page, we know that the fifth root of 32 is 2. So the fifth root of negative 32 is negative 2. Then I have to raise that to the 4th power. So a negative 2, oops, fix that, sorry. A negative 2 times a negative 2 times a negative 2 times a negative 2 makes a 4 times a 4, which makes my answer 16. Letter C, I'm going to take the negative and put it out front, and then I'm going to do the 4th root of 16, and then I'm going to cube it. So I have negative 1 up front. The 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. So now I have 2, but I have to raise the 2 to the 3rd power. So 2 times 2 is 4, times 2 more is 8, and then I have the negative 1, so the answer is just negative 8. Letter D, I'm just rewriting it. There's no numbers here to simplify, so I'm going to write x to the 5th power, the 6th root, or you could have written same exact thing. Neither one is more right than the other. I could have written the 6th root of x to the 5th. Similar for the next one, I have the 3 out front, and then the x is to the 2nd power and cubed rooted. So 3 cubed root of x and then squared. Letter F is 2p to the 1st and then square root. We don't need the 2 or the 1 though, so we can just write 2 square roots of p. The last one's a little bit trickier, but we got this. The last one, I'm going to write 3a plus b. This gets raised to the 3rd power, and then I just take the 4th root. So the trick is to leave the parentheses and make sure everyone gets the 3rd power. Okay, so now we'll try to go the other way. I'm going to give you the radical form, and we're going to do writing in an exponential form with exponents. So the first one, letter A, is x to the 5th power over the 4th root. It's always power over root. Letter B, the whole quantity 3y is under the radical, so it's 3y to the 1/2, or you can write 3 to the 1/2, y to the 1/2. Letter C, let's not get tricked by anything. The 10 hangs out front. The z had a 2nd power on it, and it was under the 5th root. Letter D, 5 out front. 2x to the 4th raised to the 7th. And then it's going to be the 3rd root, so over 3. And then I can distribute that power, so it's 5 times 2 to the 7 thirds times x, 4 times 7 thirds, 28 thirds. So it's x to the 28 thirds. Do not break up this radical. If it all is into the house, it has to stay together. It was all into the square root house, which I can write as the 1st power over the 2nd root. Okay, so when we take roots, there's something we need to be a little bit careful of. So if n is an even number, or an even positive integer, then when we take the root, we need to make sure that we take the absolute value of it. So for example, if I have the 4th root of a to the 4th, 4 and 4 are even numbers. They're the same. They should match. So it's not just the answer isn't a, but the absolute value of a. But if n is odd, then let's do 5 square root a, or sorry, 5th root of a to the 5th. Well, that 5 is odd, so then I don't need the absolute value. The answer is just a. So letter A down below is a little tricky. So I have p to the 4th power. And that power doesn't match the square that's out here. So I can rewrite p to the 4th as p squared times p squared. So it gets me the square root of p squared times p squared. So this is the same thing as saying p squared. The other way you can look at it right here is saying p to the power over root. 4 divided by 2 is 2, p squared that I have right here. And because all these numbers were even, the 2's, I have to actually do the absolute value of p squared. So on letter B, these are even numbers. So my answer is going to have absolute values in it. I get p to the 4th power divided by 4. 4 divided by 4 is 1. So it's just a p to the 1st, and it's the absolute value of whatever p to the 1st is. Okay, so the next one, you can do them each individually. So I'm going to do square root of 16, square root of m to the 8th, square root of r to the 6th. Square root of 16 is 4. Square root of m to the 8th is like m to the 8th power over the 2nd root. R to the 6th power over the 2nd root. So this is 4m to the 4th, r to the 3rd. Since all those powers were even up here to start with, they were all even, I'm going to do the absolute value of all of it, and then I'm going to go piece by piece. The absolute value of 4 is 4. M to the 4th is only going to result in a positive. So if I do anything, I'll do -1 though. But if I do anything 4 times, so -1 times -1 times -1 times -1, negative times a negative makes a +1. -1 times a -1 makes a +1. 1 times a 1 is a 1. So m to the 4th is always going to result in a positive, so I don't need to worry about absolute values, so m to the 4th. But now this r to the 3rd thing, something to the 3rd power, like if I took away one of these negatives, this would be a negative. So the r to the 3rd has to keep the absolute value signs around it. So that's the final answer. So there's this one, There's that one. Let's try some more. So on letter D, you see how the 6 and the 6 are both the same number? So we can apply our rule right away that this is going to be either -2 to the 6 over 6 power, which makes -2 to the first, and then worry about the absolute value, or just following this rule that's up top in the green box, I can rewrite this just as the absolute value of -2. Because it's even, I have to do the absolute value of a -2, and by even I mean the powers right here were even numbers. Absolute value of -2 is 2. On letter M, these are odd powers. So I can just do m to the 5 over 5, which is m to the first, which is just m. And because 5 is odd, I don't have to worry about absolute values. Letter F, there's a square root here. So letter F looks just like D and E. So because they're even, I'm going to have to worry about absolute values. So I'm going to do the absolute value. Actually, let me simplify the powers first. So I'm going to get 2k plus 3 to the 2 over 2 power, which is just 2k plus 3. And then I do have to take the absolute value of the whole thing because the powers were even. So absolute value of 2k plus 3 is my final answer inside of absolute values. Okay, so for letter G, we can factor this. I need something times something that multiplies to make the +4, but adds to make the -4. So a -2 times a -2 makes a +4, and a -2 plus a -2 makes a -4. So I can rewrite this as the square root of x minus 2 squared. There's a square power here, or the square root is the 2, which equals x minus 2 to the 2 over 2, which is x minus 2. These powers were all even, so I need the absolute value. There is your final answer. I'm definitely not sure what happened to this box, but in your notes, it should show up just fine. I think it's just I imported it, but there's a box of a recap of rules here. And so now we're going to the next page, and we're going to use those rules. So on letter A, they both are inside the square root. And since they're both inside the square root, I can combine them. But rule of thumb, before you combine anything, try to make things smaller before you make things bigger. So on letter A, I have the square root of 6. I can break 54 into the square root of 9 and the square root of 6. These are both the square root. I could have written it like this, 9 times 6. And then I can take the square root of each one of them separately, only because I am multiplying. This right here, breaking them apart, only works because I'm multiplying. If it were adding, can't do it, only because I'm multiplying. So now, I have right here and right here, the square root of 6 squared, which makes just a 6. And then right here, the square root of 9 is a 3. And then 6 times 3 is 18. So 18 is my final answer. Letter B, I'm going to rewrite them. So I can do power over root. So this is m to the first power over the third root times m to the second power over the third root. And in the last section we did power rules. Because these bases right here are the same, I can add those powers. So it's like m to the 1/3 plus 2/3. 1/3 plus 2/3 is 3/3, which is the same thing as m to the first, which gets me an answer of just m. Okay, letter C. So I get the square root of 7 on top, and then on bottom I can square root separately, square root of 64. Square root of 64 is 8, so this is the square root of 7 over 8. Letter D. On top, I have the 4th root. Just want to make that a little bit more legible. On top, I have the 4th root of A. On bottom, I have the 4th root of B to the 4th. I'm going to leave the top as a root. But on the bottom, just so you believe me, 4 as a power divided by the 4th root is B to the 1st, which is just B. So I have the 4th root of A on top over just a plain B on the bottom. Letter E looks a little bit daunting, but we're going to go piece by piece. So I'm going to take just this inside piece first. So that inside piece is 2 to the 1st power divided by 3. So now when I rewrite this, I have the 7th root of 2 to the 1/3. So now what I really have is 2. The power here is 1/3. The root now is 7. So if I take just this piece right here, I have 1/3 divided by 7. It's the same thing as 1/3. That's called 7 over 1. And you learn to keep the top fraction, change to multiplication, flip the fraction. So it's the same thing as 1 over 21. So my answer here is 2 to the power of 1 over 21, which I can write as the 21st root of 2. So let's try letter F, same idea. I'm going to get 3 to the 1/2 power, and then the 4th root of that. So that's going to be 3 to the 1/2 divided by 4. 1/2 divided by 4 over 1 gets me 1/2 times 1 over 4. It's 1/8. So it's the same thing as 3 to the 1/8 power, which I can write in radical form as the 8th root of 3 to the 1st. So now we're going to combine all these rules together. What we've been doing right now is one little thing and apply the rule, one little thing and apply the rule. So now we're going to add and subtract expressions and multiply them that have radicals in them while applying the rules at the same time. So take a second and read the green box. Give you some hints and some rules to follow by to tell if what you have is simplified. Okay, so hopefully you read that green box, and now we can do this. Okay, so let's simplify the square root of 175. So the easiest way to break this apart is 25 times 7. I can square root them both separately. The square root of 25 is 5, so this is 5 root 7. Letter B, the -3 out front stays there. If the 5th root of 32, well, 32 is 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. Times another 2 makes 8. Times another 2 makes 16. Times another 2 makes 32. So 32. The 5th root means I need to make a group of 5. So there's 5 of them. I made one group. Since I made one group, 2 gets to come out, and there's nothing left inside the radical. So I have negative 3 times 2, which is negative 6. Letter C. Everyone underneath here needs to be the cubed root. So cubed root of 81, cubed root of x to the 5th, cubed root of y to the 7th, cubed root of z to the 6th. Okay, cubed root of 81. Well, 81 is 3 times 3 to make a 9, times another 3 times another 3 to make the other 9. So if I cubed root this, I need to make a group of 3. I make one group of 3, so 1 3 comes out, but this 3 has to stay inside the root, like this. This right here is x to the 5 thirds, y to the 7 thirds, the power over root, and then z to the 6 thirds, power over root. Okay, the 3 and then the cubed root of 3 is going to hang out for a second. 3 goes into 5 one time, so I have x to the 1st, and then 2 left over, so x to the 2 thirds. We add those powers, so if I add x to the 1st times x to the 2 thirds, you add 1 plus 2 thirds. 1 you can write as 3 over 3. 3 over 3 plus 2 over 3 is 5 over 3. So all I've done is rewrite that. This is called an improper fraction, and I've written it as a mixed number. So same idea with the y. The y, the 3 goes into the 7 2 times, and then I have a y with a 1/3 remainder left over. And then for the z, 3 goes into 6, just 2 even times. So I'm going to go through and I'm going to take my variables that have a whole number power. So let me actually erase this real quick. So I'm going to take my 3 out front right here. I'm going to have an x to the 1st. I have a y squared, and I have a z squared. Now I have things left over, and if you look at the things left over, they all are in a cubed root. So I can write the cubed root, and I'm left with 1 3 inside a root. This right here says that I have x squared in the cubed root, and then right here I have y, or y to the 1st, inside the cubed root. Okay, so operations radicals. So now we're going to get to the part where we add and subtract them. This is where you need to be very careful that the thing under the root matches before you start adding them up. So for example, if I had 2 root 3s plus 3 root 2s. This is a root 3 and this is a root 2. I cannot add them, so this stays as it is. But if I had 2 root 3s plus 6 more root 3s, see how the root 3s are both the same? So that means there's 8 root 3s. Oops, I wrote 8. 8 root 3s altogether. So if I look at the first one, 11pq is the same thing as 11pq, and they're both the 4th root. So this says we have 3 of this thing minus 7 of the same thing. So 3 minus 7 is a -4, and that thing is the 4th root of 11pq. The next one, they're not quite the same, so let's clean it up a little bit. So I'm going to use blue for this first piece. For that first piece, I can rewrite this like this. 2 times 49 is 98. And then I have x cubed, and then a y. So in this group, remember the rule out front is I have to have a square or a group of 2. So in this group, I can take, there's one group of x's, so I get to get one x to pop out. And then the square root of 49 is 7, so I can get that 7 to pop out. In other words, 7 times 7 is 49. There's a group, and the 7 pops out. So inside of this, I am left with the square root of this 2, one of my x's, and a y. So this piece is 7x square root of 2xy. This piece right here has a 3x in front, so I'm going to leave the 3x. 32 is the same thing as 2 times 16, xy. The square root of 16, well, 16 is 4 times 4, so I can make a 4 pop out. So now I'm going to have a 3x times the 4 that popped out, and then in here I still have a 2, an x, and a y. So this is going to be, it's a plus in the middle, plus 12x square root of 2xy. So I have square root of 2xy, square root of 2xy, that matches. Here there's 7x of them. Here there's 12x of them. So 7x's plus 12x's makes 19x, and then that thing is square root of 2xy. Do the same idea for this one that I did for the last one. I'll do it in pieces. So let me take this piece first. So cubed root of 64. Well, 64 is, oops. 64 is 4 times 4 for 16 times another 4 to make 64. And then I can write 1, 2, 3, 4 m's, because m to the fourth. 1, 2, 3, 4, 5 n's. I have to make a group of 3. So there's one group of 4s, one group. So 1 4 pops out. There's one group of 3 m's, so 1 m gets to pop out. There's one group of 3 n's, so an n gets to pop out. And then we're left with the cubed root of, in here I have this m right here, and I have 2 n's over here, and n times n we call n squared. This piece I'm going to take over here. The equation had a minus in the middle, so minus. Now let's do this blue stuff. So this stuff, I have the cubed root of negative 27. So negative 27 is a negative 3 times a negative 3 times a negative 3. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and my house isn't big enough, but I'm going to have to draw my ends now. 14 ends. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The rule is I have to make a group of 3 to make it pop out. I have a group of 3 negative 3s, so 1 negative 3 gets to pop out. One group of m's, 1 m. Another group of m's, another m. Another group of m's, another m. And I'm left with this 1 m on the inside. One group of n's, another group of n's, another group of n's, another group of n's, and then we're left with 2 of these in here. So I'm left with the cubed root of m, and then n times n is n squared. So let's write this one more time. 4mn cubed root of mn squared. Minus, minus, make this become a plus. Plus, this is 3m. M times m times m is called m cubed. And then n times n times n times n is called n to the fourth. And this has a cubed root of mn squared. Now here's the problem here. The radicals are absolutely the same. This is the same as this piece, but what's not the same is the variables here and the variables here. I have mn versus m cubed n to the fourth, and I cannot add mn to m cubed n to the fourth. So what I can do is pull out that yellow piece that I've underlined. So since those two yellow things are exactly the same, I'm going to factor them out. I'm going to pull it out of both of them. So I take out the cubed root, or third root of mn squared. So I've pulled that out of both of them. What's left in the first thing is 4mn plus in the second thing 3m cubed n to the fourth. So we're going to do power over root. I get 3 to the second power over the sixth root, which simplifies to 3 to the 1/3, which is the same thing as saying the cubed root of 3. Same idea with letter B. X to the 12 power over sixth root, y to the third power over sixth root. 12 over 6 is a 2. 3 over 6 is a half. So this is x squared, and then the square root of y. Next one we're going to do in pieces. So I'm going to do the 6 I'm going to do this inside piece first. It's 6 to the third power with a square root. So now I have the 9th root of 6 to the 3 halves. 6 to the 3 halves power divided by 9. So that's 3 over 2 divided by 9, or 9 over 1. Keep, change, flip results in 3 over 18, and 3 over 18 reduces to 1/6. So now I have 6 to the 1/6, which I can write as the 6th root of 6 to the first power. Okay, we're going to FOIL. We got this. So I'm going to do square root of 7 times square root of 7. I'm going to write it all the way out. So this is the square root of 7 times the square root of 7. And then I'm going to do square root of 7 times square root of 10. So plus square root of 7 times square root of 10. Negative root 10 times root 7 is a minus root 10, root 7. Negative root 10 times a positive root 10 is negative root 10 times a root 10. Now piece by piece. This is the same thing as the square root of 7 squared, which is a 7. This is a positive, and this is a negative. They're exactly the same. This is a plus root 70 because they live in the same house. You can multiply them back together. This is a minus square root of 70, so they cancel each other out. So then I'm going to take this minus sign right here, minus. This right here is the square root of 10 squared, which is just 10. So 7 minus 10 is negative 3. Let's try again. Root 2 times root 8. Root 2 times negative 5. Negative 5 root 2. We usually write the whole number and then the root after it. 3 times root 8. So plus 3 root 8. And then 3 times minus 5 is a minus 15. This can get multiplied back together and make the square root of 16. Minus 5 root 2 plus, 8 is 4 times 2. The square root of 4 is 2, so I can pop a 2 out. Let me pick this over here. 3 root 8 is the same thing as 3 times the square root of 4 times the square root of 2. The square root of 4 is 2, so this is 3 times 2 times the square root of 2, so it's 6 root 2. So this is plus 6 root 2 minus 15. Square root of 16 is 4. These are both the same root, so negative 5 of root 2's plus 6 root 2's makes 1 root 2, and then minus 15. 4 minus 15 is negative 11 plus my root 2. Okay, we learned this skill in Algebra 2 and maybe a little bit in geometry. We don't leave roots or radicals in the denominator. So we're going to multiply by what we're missing. So this is a square root. So I need one more root 3. There's one here and one here. So these two powers here would make a 3 squared, and it's the square root. So a square and a square match, and then I'm good. Hold on to that thought. It's going to be helpful in the next problem. And so if I multiply the root 3 on the bottom, I have to do the same thing on top. So it's like multiplying by 1. So I get 4 root 3. Root 3 times root 3 just becomes a 3. Let's try the next one. I'm going to break the next one apart. So this is the same thing as the 4th root of 3 over the 4th root of 5. And this is what I was talking about a second ago. So right here, I have the 4th root of 5 to the 1st. I need 3 more to make the 4 and the 4 match. So I'm going to multiply by the 4th root. You want to leave it in the same kind of root of 5 to the 3rd. 4th root of 5 to the 3rd. And if you want to check why, right here, they live in the same house. So I'm going to get the 4th root of 5 to the 1st, 5 to the 3rd. And you add those powers. You get 4th root of 5 to the 4th. The 4th root and the 4th power undo each other, and this is just 5. That's the whole idea, to get rid of the radical on the bottom. Okay, so multiply straight across. So on the top, they both live in the 4th root, so I get the 4th root of 3 times 5 cubed over the 4th root of 5 to the 4th, which we just talked about right here. It's going to undo each other, so I'm going to get the 4th root of 3 times 5 to the 3rd over 5. And I'm just going to clean it up a little bit. 4th root, 5 times 5 is 25. Times 5 is 125. Times 3 is 375. So that top part, this numerator, is really the 4th root is 375 over 5. Okay, so we're going to multiply by what we're missing. So on the top and the bottom, we're going to multiply by the same thing. So I'm multiplying by 1. So I should do the 4th root. I need one more x to make that an x to the 4th. And I need 2 more y's to make it a y to the 4th. And if I do that on bottom, then I have to do that on top. So on the bottom, I'm going to get the 4th root of x to the 4th, y to the 4th, which is exactly what we wanted. But on the top, I get the 4th root of this x times another x makes an x squared. This y cubed times a y squared is a y to the 5th. So this equals the 4th root of x squared y to the 5th, which I'll clean up in a second, but on bottom I get an xy. So I've handled the first problem that there is a radical on the bottom. Okay, on the next one, I'm going to rewrite it first. So I get 5 to the 1/3 over x to the 6/3 power over root minus 4 to the 1/3 over x to the 9/3. So on top, I have x to the 5/3. 6 divided by 3 is 2, so I get an x squared minus 4 to the 1/3. 9 divided by 3 is 3, so I get x to the 3rd. So if I wanted to add fractions, if I wanted to do 4/5 plus 1/20th, I would multiply this fraction by 4 over 4. Get common denominator, I get 16 over 20 plus 1 over 20. That's what I'm going to do down here. My first fraction needs one more x. So if I multiply by x over x, I get 5 to the 1/3 x. X times x on the bottom is x to the 3rd minus 4 to the 1/3 over x to the 3rd. And now because my denominators are the same, I can rewrite this as 5 to the 1/3 x minus 4 to the 1/3 all over x cubed. And then instead of writing powers that are fractions, I'm going to write the roots. So I have x, and then it's the 3rd root of 5 minus the 3rd root of 4 all over x cubed. Last one. So this is called rationalizing the denominator. I can't just multiply by root 2 over root 2. I have to multiply by what's called the conjugate, and that means you change the sign in the middle. So you do 1 plus root 2 over 1 plus root 2, and we're going to have to FOIL. So on top, 1 times anything is the other thing. So I get 1 plus root 2. On bottom, I'm going to have to FOIL. So 1 times 1 is 1. 1 times root 2 is plus root 2. Negative root 2 times 1 is negative root 2. Negative root 2 times positive root 2 is going to negative root 2 squared. These two are going to cancel off. So I have 1 plus root 2 on top over 1 minus square root of 2 squared is 2. So this is 1 plus root 2 all over a negative 1. I'm going to divide both pieces in the top by a negative 1. So 1 divided by negative 1 is negative 1. Root 2 divided by negative 1 is negative root 2.